Welcome to section 7.3. For section 7.3, we're going to be learning about squaring and square roots, which you've come across before. We're going to learn about those in function form also. We're going to learn about a friendly window in our calculator. We might take care of that in class rather than in the video. And we're going to compare squaring functions to other types of functions. We're also going to learn how to solve equations that involve squares, square roots, and also absolute values. And you've done a little bit of that with absolute values already. All right, so we're talking about squaring, right? So here's just some artwork that comes with using perfect squares. All these ones might not be quite so perfect, but still comes from using squares, right? You'll see a lot of that in mosaics. When I say squaring, what I'm talking about is raising to the power of 2, right? X squared, or 9 minus y squared, or 370 squared. So we're not going to say to the second power. When we say this, we're going to say squared, right? We're talking about a perfect square. Well, I'm going to go back a second here. I don't want to skip anything. All right, let's take a look at a quick example of a square root then. So squaring is squared. A square root is going to be this sign right here, right? This is called a square root sign or a radical. It's also called a radical. So what is a square root? It's what value multiplied by itself is that number. So when I say the square root of 25, I'm saying that 5 times 5 is 25, right? Square root of 100, 10 times 10 is 100. Now, take a look at this one real quick. So where does this plus or minus come from? So square root of 400 is 20, because 20 times 20 is 400. But in reality, 400 has 2 square roots. It has a positive square root and a negative square root, because 20 times 20 is 400, and negative 20 times negative 20 is also 400. So there are actually 2 square roots of 400, a positive 20 or a negative 20. Okay. The positive square root is also called the principal square root. So when I say the principal square root, or what is the principal square root of 400, I'm saying positive 20. But again, there are 2 square roots, 20 and negative 20. So we have this other function now. We have y equals x squared. So we've looked at linear functions. We also took a look at absolute value functions and what those look like, right? That's that V shape. But we have another one called y equals x squared. So what shape is that going to give? That's going to give, well, I'll get to the shape in a second. So when we enter y equals x squared into our calculator, so if you go to your y equals key, right, you can enter it in 2 ways. There is an x squared key, so you can just enter it as x squared with the key, or you can say x and then you can do to the power of 2. Those are both ways to use to enter in this y equals x squared function into our calculators. Now, what does that graph look like? It looks like this U shape, right, which we call a parabola. So we get a parabola from this function, y equals x squared. That's where we get that shape. This bottommost point is called the vertex, okay? We can also refer to that as the maximum or the minimum. Now, in this case, in this particular parabola, this is a minimum, because it's the lowest point in the graph. You could have a parabola that looks like this, right? It's just kind of flipped around. In that case, that would be, it's still a vertex, but that would be called a maximum because it's the uppermost point in the graph. So vertex and then maximum, minimum, you can use interchangeably, but only maximum if it's the uppermost point and only minimum if it's the lowermost point. In our y equals x squared function, our basic parent, we call it a parent function. Y equals x squared is a parent function. Your vertex is always going to be at 0, 0. in this function y equals x squared. When I start adding other numbers to that, your vertex is going to change. But in your parent function, your vertex is at 0, 0, or the origin of the graph. And I think this we're going to cover in class. So let's look at some examples of solving equations when I have squares and square roots. So you're simply going to use reverse order of operations, or you're going to undo, right? Remember those do-undo tables. You're going to do the same thing here. So this is x squared minus 4 equals 21. Well, when I do things, I would take care of the exponent first, right? But when I undo something, I'm actually going to take care of this first. So I'm going to add 4 to both sides, and I'm going to say x squared equals 25. How do I undo a square? I undo a square by using a square root. So when I use the square root, I'm undoing that squared, that second power. So I'm left with x equals 25. True, false? Square root of 25 is not 25, right? What times itself is 25? That's going to be 5, right? So square root of 25 is 5. Now remember, there's a principal square root and also a negative square root. So I'm actually going to say it could be positive 5, and it could also be negative 5, right? So that would be that first example. Let's take a look at another one. Again, undo, right? So undoing, or reverse order of operations, says that I'm going to add first. So I've got 3 times x plus 9 squared equals 27. Again, undo says I'm going to next divide. So now I have x plus 9 squared equals 9. And again, undoing says I'm going to do the square root. To undo a square, I use a square root. So again, that gets rid of my second power, and I'm just left with x plus 9. And on my right-hand side, the square root of 9 could be a positive 3, but again, it could also be a negative 3. So this is where it gets a little bit interesting. So now here I'm actually going to split this up. So I'm going to say x plus 9 equals positive 3, and I'm also going to say x plus 9 equals negative 3. And I'm going to solve those two equations separately. So here I'm going to subtract 9, and I've got x equals negative 6. I'm going to subtract 9, and I've got x equals negative 12. So I have 2 solutions when it comes to a square function, an x squared function. I have a negative 6, and I also have a negative 12. Now, if I look back up at that shape that is made by that function, notice that I have a point on this side, and I have a corresponding point on that side. That's why I'm getting 2 values of x, right? For every value of y, right? So when y is, let's see, 1, 2, 3, 4, 5, when y is 5, x could be 2, and x could also, sorry, that's a negative 2. X could be a negative 2, but x could also be a positive 2, something like that. Now, that's not exactly true in this case. If we were to solve this correctly, if x was 5, then y would be what? 1, 2, 3, 4. Well, we're not going to go there because that's going to be way above the graph. So all you need to know right now is that for each value of y, you have 2 values for x, which is why in our example, we are getting 2 different x's. X is negative 6, and x is also negative 12. Let's look at another one. So here we don't have our squared function, we have our absolute value function. Now we've done these already, right? We're going to subtract 4, and we get the absolute value of x equals 6. We need to remember that whatever is inside of that absolute value could be what? A positive or a negative, right? So x could be positive 6, and x could also be a negative 6, right? Again, two solutions. Both a positive and a negative 6 are going to work in there, right? Because the absolute value of 6 is 6, and the absolute value of negative 6 is also 6. If you remember the shape that that absolute value function makes, it's that V, right? Which sort of looks like the parabola. It's a V instead of a U. So again, just like the other one we talked about, for every one value for y, I have 2 values for x, which is why I'm getting 2 solutions. I'm going to start this one. I'm going to pause, and I want you to finish it. So to undo, I would start by doing this, right? Minus 8, and I've got the absolute value of x plus 5 equals 2. From here, there's nothing else to undo. I can't subtract 5 because it's on the inside of my absolute value. So this is actually where I'm going to split it up into 2 pieces. So now I have x plus 5 equals, and x plus 5 equals, and I want you to fill in the blanks and continue to solve so you get your 2 solutions. All right, so did you get the same thing I did? So I filled in the blanks with a 2 and a negative 2, so x plus 5 could be 2, or x plus 5 in that absolute value could also be negative 2. Then I went ahead and subtracted 5 from both sides. I did that with both of my equations, and I ended up with x equals negative 3 and x equals negative 7. Let's just look at a couple more. So this is not our squared function. It's also not an absolute value function. This is a square root function, right? I don't have x squared, I have the square root of x. So here we have a square root function. I'm still going to undo the same way I was undoing the other ones with my reverse order of operations by adding 10 each side of the equal sign. Now I have 3 times the square root of x equals 18. So it's just a square root of x instead of x squared. What did we do from here before? In my reverse order of operations, I divided by 3. My goal really is to get that square root of x alone so that I can get x alone. So now I've got the square root of x equals 6. Well, how do I undo a square root? Remember, we undid a square by doing the square root of, right? So we're going to undo a square root by squaring. So we undo a square by taking the square root. We undo a square root by squaring. So what that does is it eliminates that radical or that square root sign. So what I'm left with is x. Oops, one thing I didn't do though is do the square root of 6. Or not the square root of 6, making all sorts of mistakes today. We squared this side, so I'm going to square that side also. So I square both sides, and I'm left with an x equals 6 squared, or 6 times 6, which is 36. So there's my one solution to this function. This doesn't have 2, this only has 1. All right, one more to finish us off today. Reverse order of operations. I'm going to start this and then I'm going to finish it. So I've got what? 8x squared equals, be careful, this is negative 14 and negative 2, which is negative 16. I'm going to pause and have you finish. Did you get stuck? I got stuck, and this is why. Because when I got to this step where I did the square root of both sides, I'm trying to do the square root of negative 2. Well, what number times itself is a negative? There isn't anything that you can multiply by itself to get a negative, right? I can't do, you know, a negative times a negative because that's going to give me positive. Can't do a negative times a positive because those are 2 different numbers. I can't multiply anything by itself to get a negative number. So now what? What I'm going to say is no real solutions. So there are going to be some of these where you can't finish solving it. You're going to say no real solutions in that case. And we're going to end there for today.